Have you ever stopped to think about a smart factory as, well, a living, breathing thing? I mean, picture it. You've got this central brain making all the big strategic decisions. But here's the question. What good is a brain if it doesn't have nerves? You know, a way to actually feel what's going on and to send commands out. Today, we are diving deep into that very nervous system, the Industrial Internet of Things, or what we call IIoT.
So, here's the game plan. We're going to start with the basics, the factory's brain and its nerves. Then we'll get into the weeds of the huge communication problem they have to solve. After that, we'll break down the three main goals of IoT, see how it all works in a couple of real-world situations, and wrap up with why that final mile of connection is absolutely everything. All right, let's get right into it with our big idea, thinking of the factory as one big, complex system, almost like a body.
At the very heart of this system, you have the MES, the Manufacturing Execution System. Now, this is the brain. It's the command center. It's what figures out what to build, how to build it, and in what sequence. The entire blueprint for production, from start to finish, lives right here. It's calling all the shots.
But, you know, a brain can't do its job in a box. It needs to know what's happening in the real world. And that's exactly where IIoT comes into play. The Industrial Internet of Things is the factory's nervous system. Think of all those sensors on every machine as the nerve endings. They're feeling the temperature, counting parts, sensing when a job starts or stops. They shoot all that vital info back to the brain. And just as important, they carry the brain's commands back out to the floor. Without IIoT, that fancy MES brain, it's completely blind and deaf.
So it sounds pretty straightforward, right? Just connect the nerves to the brain. Well, this is where the dream of smart manufacturing often hits a massive brick wall. Let's dig into why this connection is so ridiculously hard to pull off.
And it's a perfectly good question to ask. I mean, if the idea is that simple, why is it such a nightmare to get all these different machines to just talk to each other? Well, the answer is in the beautiful and sometimes maddening chaos of a real factory floor. There's this great metaphor for this problem called the 8-Nation Alliance Challenge. Just imagine a factory floor. We've got machines from a dozen different companies, from a dozen different decades. It's like an international campout, but nobody speaks the same language. It's organized chaos at its finest.
And this really shows you what we're up against. It's not just one language barrier, it's dozens. You've got your basic machine controllers, the PLCs, and there are over 200 different types. Then you've got the CNC controllers from big names like Fanuc, Siemens, Mitsubishi, and they all speak different dialects, use different protocols, and format their data differently. Trying to get them all on the same page is like trying to host a UN summit where you forgot to hire any translators.
Okay, so in the middle of all this chaos, what is IIoT actually supposed to be doing? Its job isn't just to open up a phone line. It's about getting the right message to the right place at the right time. So let's break down the three big goals of any IIoT system worth its salt. It really all boils down to these three things. First, you have to collect the raw data from the machine. Second, you have to know when to collect it by identifying the key events that actually matter. And third, and this is the big one, you have to connect that data to the MES to give it all meaning.
Now, this is a really important distinction. IIoT is not about opening a fire hose and flooding the system with data 24/7. That's just noise. It's about being surgical. You figure out what data you need, like temperature, pressure, or a part count, and then, critically, when you need it. By grabbing that data only at key moments, like when a process starts or ends, you're automating what people used to do by hand, which cuts out mistakes and saves a ton of time.
But here's the thing. Even if you collect the perfect piece of data at the exact right millisecond, it's not enough. And that leads us to that third and honestly most important goal. Because if you have a temperature reading but you don't know which product was on the machine at that time, that data is completely and utterly useless.
So this is where the magic happens. The final, crucial job of IIoT is to talk to the brain, the MES, and bind that machine data with some context. It takes that temperature reading and attaches it to the specific product ID, the work order, or the lot ID that the MES is tracking. That's when the data becomes powerful. That's how you can trace a problem with a product all the way back to the exact conditions on the machine that made it. Okay, so we've got the what and the why. So what does this actually look like on a real factory floor? Well, this whole conversation between the brain and the nerves can play out in very different ways. Let's walk through two totally different scenarios.
So on one side of the spectrum, you have your super high-tech, highly automated factories. Think semiconductor manufacturing.
And on the other side, you have more traditional factories that really rely on their human operators. And the single biggest difference between them, it's who starts the conversation. In the automated world, the machine talks first. In the traditional world, the person does. So let's look at scenario 1, the automated handshake. Picture this. A product arrives at a machine. The machine itself has a sensor. It reads the product's ID, and it pings the IIoT system. The IIoT then acts like a messenger and asks the MES brain, hey, this product just showed up. Am I good to go? The MES checks its master plan, confirms everything's in order, and sends back the track-in command. Just like that, the machine gets the green light and starts the process, all by itself. It's a totally seamless machine-to-system conversation. Now, let's compare that to the much more common scenario, the manual assist. Here, the machines aren't quite smart enough to kick things off, so a human operator walks up, grabs a scanner, and zaps a barcode right into the MES interface. They're telling the brain, okay, I'm starting this job right now. The MES then tells the IoT, okay, start listening. The IoT starts pulling data from that machine and, this is key, it binds all that data to the lot ID the operator just scanned. When the job's finished, the operator scans again to signal track out. In this world, the human is the essential bridge.
And that really brings us to the big finish. All this complexity, all these different scenarios, they all point to one single critical idea. It's the importance of closing that final gap between the digital brain and the physical world on the floor. It's all about making the factory feel.
There's a quote that just nails this perfectly. For a factory to be responsive, its equipment needs a voice. I mean, think about it. If a factory can't sense what's actually happening moment to moment, there's no way it can react. It can't adapt to problems. It doesn't matter how smart the brain is. If it can't feel anything, it's flying blind.
And that, right there, is the ultimate job of IIoT. It is the last-mile bridge. It's the translator that connects two totally different worlds, the physical world of the machines, which we call OT, or operational technology, and the digital world of the software, the IT, or information technology. IIoT is what turns the raw signals and vibrations of the machines into structured data that the brain can actually understand and use to make smart decisions.
So, let's wrap this up with the key takeaways. First, IoT is not just a passive tool for collecting data. Its real purpose is to actively drive decisions. Second, it's that universal translator, turning all that machine chaos into a language the MES brain can actually work with. And finally, if you remember nothing else, remember this. A smart factory without a working IoT is like a brain in a jar. It might be brilliant, but it's completely numb, totally disconnected, and powerless to respond to the world around it.
Which leaves me with one final question for you. Think about your own environment, whether it's an actual factory or any other complex system you're a part of. How healthy is its nervous system? Are the signals getting through clearly? Is the brain really connected to what's happening on the ground?